Example 3. In this question, we will see what happens to an annuity when the payments change in size. Determine the cash value of an insurance policy that provides for payments of $40,000 per year for 10 years, followed by $60,000 per year for 15 years. Assume an interest rate of 12% compounded annually. Let us begin with a time diagram. First of all, we have annuity payments of $40,000 at the end of every year for the next 10 years. So that's 10 payments of $40,000. That's followed by $60,000 payments for 15 years. So that means that we've got a total of 25 years of annuity payments, but the second annuity of $60,000 per year does not start until after the first one has been finished. So for the second annuity, we've got it starting at year 11, we've got our first payment of $60,000 and another one at year 12 of $60,000. And how many of these do we have? Well, we've got 15 of them. So that's a total of 25 years of annuity payment. So 15 more up to 25, year 25, $60,000. So if I wrap an annuity bus around the $60,000 annuity, I know that I've got a total of N is equal to 15 payments inside the second annuity bus, and N is equal to 10 payments inside the first annuity bus, a total of 25 years of annuity. Now the interest rate is 12% compounded annually, so the interest rate is per year, the payments are per year, there's no conflict here. We can certainly use the present value formulas. So the interest rate is 12% per year. We're going to use the present value formulas to put all of this together because we need to find the cash value of these insurance policy payments. The cash value means present value, so cash value and present value mean the same thing. So first of all, let's break this down into a couple of problems here. It's very easy to determine the cash value of the $40,000 payments. The cash value would be the value that we obtain at the front end of the annuity or the one interest period before the first $40,000 payment is made. So that has a present value of, let's see, that would be $40,000 per year multiplied by the discount factor 1 minus 1 plus 12% per year, 10 payments of $40,000 divided by 12% per year. Those $40,000 payments for the 10 years have a cash value or a present value of $226,008.92. You can store that number in memory 1 if you like, but what would even be a better idea would be to put it on your time diagram where it is appropriate or where it belongs. And in this particular case, the present value of the $40,000 payments is $226K. So I'm going to put that at the front end of the $40,000 bus. Now we need to do something about the $60,000 annuity. So let's take a look at it. Again, we have 15 annual payments of $60,000, and I can easily calculate the present value of those $60,000 annuity payments. That would be $60,000 multiplied by the discount factor for a present value annuity, and that would be 1 minus 1.12. The exponent is negative 15 because there's 15 annual payments of $60,000 divided by 0.12. That's 12% per year, $60,000 per year. The present value of that $60,000 annuity is equal to $651.87. Now I'm going to round that off to the nearest penny, but you would probably be best off if you stored the full amount in memory 2. Store that in memory 2 because you're going to need it. What would be an even better idea now would be to take that $408,000 and place it on your time diagram where it belongs. It is the present value, it's calculated as the present value of the $60,000 annuity. So technically it belongs at the front end of that $60,000 annuity bus. So the present value is $408K. And I'm just going to use the short form here. $408K is the present value of the $60,000 bus. So what do you think we're going to do now? In order to determine the cash value of these two annuity payments, how do we determine the cash value? Well, the cash value assumes a focal date of today. So what we have is we have 226K today, but in order to find the present value or cash value of that $408,000, what we need to do is we need to bring it back to today's date. So how do we do that? We need to multiply that $408,000 by the compound discount factor over a 10-year period. So we need to multiply that by 1 plus I to the negative 10 exponent, discounted over the 10 years. So that will be another step in our problem. So now what we're going to say is the present value of that amount is $408,000, 651.87 multiplied by 1.12 to the exponent negative 10. And when we work that out, we end up with a cash value today of $131,574.97. And so we can store that in memory 3 because that is going to be the cash value of the $60,000 annuity. So it's 131K. I'm going to put that on my time diagram. So now what do? I simply take the 131K and I add it to the 226K, and that will give me the combined value of both annuities. And so when I add these two amounts that have been stored in memory, we've got cash value is equal to the 226K plus the $131,000, giving us a total cash value of $357,583.89. And so this concludes our few examples on determining the present value of an ordinary simple annuity. Remember that with a time diagram, an ordinary simple annuity has present value, focal date, one interest period or one payment period before the first payment is made. The present value is always the value of the payments without the interest. The interest is not included in the cash value. However, the interest can be calculated by the difference between the cash value and the sum of all of the payments. So the discounted value is always going to be less than all of the payments combined. And here's a very good example of a time diagram showing an ordinary simple annuity with end payments of $R.